Okay, pre-calc. Lesson 1.2 is on graphs of equations. So our first example, our points 1, 3, and negative 2, 4, solutions of y equals 8x minus 5. So what we're going to do is take the first one and we substitute the x, y values. So we write it, the y value 3 equals, we'll put a little question mark because we're trying to figure out if it's true. 3 is equal to 8 times 1 minus 5. Well, that happens to be 3 is equal to 3, so that is true, and we just put a check mark. So let's try the next one, negative 2, 4. So substitute the value of y. 4 is equal to, with a question mark, 8x, which is 8 times negative 2 minus 5. Well, 8 times negative 2 is negative 16, minus 5 is minus 21. So 4 is not equal to negative 21. So this is not a solution. Okay, example 2. Graph y equals negative 3x plus 2. So what you do is start off with a xy table. Put in a couple values. So when x is 0, y is 2. Now we could choose 1 for x, but that's going to give us a, well, we could still do that. Minus 3 plus 2, that would work. Let's choose a number that's farther away because we're going to graph this, and it's a little bit better if you have the numbers a little bit farther away. So when x is 2, so we have minus 6 plus 2, and we have a negative 4 for y. So now we can set this on a graph, draw our graph. And when you're graphing these, you want to be pretty accurate. You want to be doing everything on graph paper so your graphs look nice. Okay, so 0, 2. 0, 2 is right here. 2, negative 4, 2, negative 4, right here. And we want to graph it, so let's just draw a line between those. There we go. Now, we notice this is linear, and we knew it was going to be linear because the exponent on this x here, this x is just 1, so it's linear because it's x to the 1 power, first power. The exponent's 1, so it's linear. Okay, next example, sketch y equals 1 minus x squared. Well, we know it's a parabola because of the x squared term. We also know that the coefficient is negative, so this is going to open down. So let's just do our xy table again. Choose an easy value for x. When x is 0, y is 1. When x is 1, actually when it's plus or minus 1, y is 0. And when x is plus or minus 2, value of y is going to be negative 3. That gives us 5 points to plot, and you want 5 if you're doing a parabola. So let's go ahead and make our coordinate system. And let's put it right here, that'll work. So 0, 1, plus or minus 1, and 0. Plus or minus 2, negative 3. Okay, now this you want to sketch it. A parabola, you know that they are not pointed at the vertex, so do the best you can to kind of round it off and then try to get through all the lines. Sketching means it looks pretty good, but it doesn't have to be perfect. Okay, example 4, finding x and y intercepts for the equation y equals negative x squared minus 5x. Okay, so we know that we're going to have x-intercept at y equals 0. And we know we're going to have a y-intercept at x equals 0. So let's set y equals 0 and find the x-intercepts. So 0 equals negative x squared minus 5x. So 5x equals negative x squared. And problems like this, you want to factor out an x first. So factoring an x out, we have 5 is equal to a negative x, or x equals negative 5. So there's one solution, negative 5. When x is negative 5, go to the original equation, and it turns out y value is 0. That's only one solution. The other solution we get by factoring an x out. So from the original, let's say 0 equals x times negative x minus 5. And that's going to give us 0. And when x is 0, y is 0. So that's our other point. And then to find the y-intercept, I'll do that in red. So y-intercept, we set x equals 0. So we have y equals negative 0 minus 0. So y is equal to 0. And when y is equal to 0, x is equal to 0. Notice these two are the same point. That's going to happen a lot. So now we want to graph this and see what it looks like. Choose another color. Let's do green. So let's just draw our line. Oh, that's not a very good line. Let me redo it. Okay, so... Okay. So bottom, 0, 0 is a point on the curve. Negative 5, 0 is another. Negative 5, 0 is right here. The thing is, we don't know what the curve looks like in between, so we have to do a little more work. So we remember that the vertex, because this is going to be a parabola, we know that because it's an x squared term, and the vertex is at x component equals minus b over 2a. Probably remember that from your work in parabolas. Well, the b is negative 5, so minus negative 5, we have 5. 2a would be a negative 2. So the x value at a negative 5 halves, that's the x value. To find the y value, we just plug it in. So y is equal to, go to our original, negative x squared minus 5x. Substitute our negative 5 halves in for x, and that's going to give us a negative 5 halves squared is going to be 25 fourths, and minus 5 times negative 5 halves, so that's going to be plus 25 halves. So negative 25 fourths and 25 halves is a positive 25 fourths. So the vertex, this is the way I write it, vertex coordinate is going to be negative 5 halves and 25 fourths. Now you notice I didn't put this in decimal. Don't use decimals unless you have to. In other words, fractions are better than decimals because they're accurate. Decimals aren't always accurate. So let's plot this vertex and see what this graph is going to look like. negative 5 halves, so that's halfway in between here. 25 fourths, well, 24 fourths is 6, so this is a little over 6. So 1, 2, 3, 4, 5, 6. So the vertex is going to be right about there. So it's a parabola. Opening down, we knew that. And so rather than getting 2 more points, I'm just going to sketch the parabola, and it's going to be something like that. So example 5. We want to know if the equation y squared equals 6 minus x, if that's symmetric. Well, we can answer that right away. We know because it's a y squared term. We know it's going to be symmetric with respect to the horizontal axis. And because of the y value is squared. So now that we know it's symmetric, let's plot this thing and see what it looks like. So again, we do our xy table. So in this case, I want to choose something that makes it a little easier. So let's choose, if x is 6, then y is equal to 0. Okay, we can plot that. Well, what about when x is 5? 6 minus 5 is 1, so y is going to be plus or minus 1. The other one we can choose, let's choose 2, because that makes it easy. 6 minus 2 is 4. Y squared is 4, so when x is 2, y is plus or minus the square root of 4, which is 2. So let's go ahead and sketch this and see what it looks like. Okay. Yeah, right away I see I need to extend this. Okay. When x is 6, 3, 4, 5, 6. Here's 6, 0, 5, and plus minus 1. 5, plus minus 1, 2, plus minus 2. 2. Okay, so we have 5 points, and we can sketch it. This is a shape of a parabola, although this is not a function. And the reason we know it's not a function is because it doesn't pass the vertical line test. We draw a vertical line and it intercepts the graph at more than one place, so we know it's not a function. Now, we're going to be dealing with quite a few problems that aren't functions, so just because it's not a function doesn't mean it's not useful. A lot of things are not functions. Good examples are circle. Circle is not a function because it will not pass a vertical line test. Okay, example 6. We want to find the equation of a circle, and we know it has point 1, negative 2 on the circle, and we know that the center of the circle is negative 3, negative 5. So let's go ahead and sketch it first, and then we'll find the equation of it. So need some coordinate grid. Yeah, that doesn't look like a very nice line. Let me try to redo it. Okay, so the center of the circle, negative 3, negative 5. 2, 3. 1, 2, 3, 4, 5. So here's the center of the circle. And we know it has a point 1, negative 2. 1, negative 2. So here's a point that lies on the circle. Now, we better not sketch the circle until we get the equation. Now, the equation we want is the standard equation. So we have to have the standard form equation of a circle, and we remember that that is x minus h squared plus y minus k squared equals r squared. And we know that h and k are coordinates of the center. So -3 is h, and -5 is k. So we can go ahead and plug it in. So we have x minus a minus 3, that's squared, plus y minus a minus 5, so y plus 5 squared equals r squared. Now we got to figure out what r is. Well, we know that the point 1, -2 lies on the circle, so that has to be the radius. And so we can draw this here, and we'll call this r, is the radius, and now we need the dimensions of that. Well, the easiest way is just kind of do our Pythagoreans, make it a right triangle. And dimension here is 4. Dimension here is 3. So r squared equals 4 squared plus 3 squared. 16 and 9, 25. 25. So r squared is 25. So now we can finish up. X plus 3 squared plus y plus 5 squared equals 25. This is our equation of the circle with the center at -3, -5, and the radius is 5. Now I could try to draw this circle, but I don't think it's going to work out too good. I don't have a compass. You could draw it if you have a compass, but you know, just for grins, I'm going to try and draw this and see what it looks like. Do it in green. Probably going to look really ugly. Well, it's not. Let me try it again. Try it again. Ah, look at that. That's not very good. At first I thought that looked pretty good, but it doesn't. So I'm not even going to draw the circle. So that's it for this lesson. And the problems, as always, are going to be listed in Google Classroom.